Okay, Wildcat. Today we're at Journal, page 67, Logarithm Properties. Okay, so exponential equations are written b to the x equals a, and logarithmic equations are written as log base b of a equals x. Now you can see if you were to convert exponential equation to a logarithm equation, the b would go here, the a would go here, and the x would go here, and vice versa. Okay? All right. Now, the first property, log base b of x times y equals log base b of x plus log base b of y. The log of a product is equal to the sum of the logs of the argument. All right. Next property. Log base b of x divided by y is equal to log base b of x minus log base b of y. The log of a quotient is equal to the difference of the logs of the arguments. All right. Log base b of x to the p power is equal to p times log base b of x. The log of a number raised to a power is the same as the power times a log. You know what? We're going to shift our camera over a little bit, try to get away from that. I guess we can't. That brightness right in this little corner is just going to have to stick with us, I guess. Try to get away from it, but I guess it's just here to stay. All right. Log base b of b raised to the p power is equal to p. If the log, base, and the argument are the same, it is always equal to the power. So in this case, log base 2 of 2 to the 6th power is equal to x. So we can say that x equals 6. So log base b of b equals 1. So log base 2 of 2 equals x. We can say that x equals 1. All right, log base b of n is equivalent to log of n divided by log of b. So if we have log base 4 of 32, that's equivalent to log of 32 divided by log of 4. All right. Log base f of x equals log base 2 of x plus 1 is equal to log of x plus 1 divided by log of 2. And we call that the change of base property. Okay, so if you would, go and update your notes. All right, now your notes are updated. Let's take a look at the examples. Rewrite the equation in exponential form. Okay, so what we probably want to do is write this up. So this is exponential form. B to the x equals a. and log base b of a equals x. So we have this form here, and we need to convert this to this. So we know that our b values here and our a values here and our x values here. Okay, so we can say that this is 2 to the 3 equals 8. Which we basically did b to the x equals a. And again, we'll do the same thing here. B to the x equals a. So 4 to the 1/2 power equals 2. That's 1, so that'd be 2 to the 3rd power equals x. Okay, rewrite each equation in logarithmic form. Okay, so this would be written as log base 2 of 8 equals 3. And the reason being is we know that log base b of a to the x. So the b value is 2. The a value is 8 equals to x. So same thing here. So that's log base 5 of 1 divided by 25 equals -2. All right, last one. So that's log base 4 of 2 equals 1 divided by 2. All right, now to evaluate, we can set this equal to x, and we have to ask ourselves, well, 5 raised to the x power equals 125. So we ask ourselves, well, what does x equals? Well, x equals 3, because we know 5 to the 3rd power equals 125. Okay, let's do the same thing for example 7. So let's set that equal to x, and we ask ourselves, well, 4 to the x power equals 1 divided by 4. Well, you ask yourself, well, 4 raised to what power x equals 1/4? Well, the answer to that is x equals -1. Okay, same thing here. Let's set that. Oh, actually, no. This case, we see that 2 raised to the log base 2 equals 1. So that's 1 to the 27th power equals 27. Oh, I take that back. I'm sorry. That's not 1 to the 27th power. That just goes away and it's equal to 27. I misspoke. I'm sorry. All right. Example 10. Expand each logarithm. Okay. So this becomes log of x plus log of y plus log of z squared. And the last thing we need to do is we know that this goes to the front, so then that's log of x plus log of y plus 2 log of z. Okay, example 11. Okay, this is log of x minus log of y to the 6th power, which then becomes log of x minus 6 log of y. Okay. All right. Now, this was expanding, so we expanded these. Now we're going to, let me underline that. We expanded here, now we're going to condense here. Okay. So then this becomes, now here when you multiply, it expands to be plus or addition or sum. Here we're adding, so to condense we multiply. So that's log of 2 times 11 times 7, which is log of 2 times 11 is 22 times 7 is 154. Okay. Example 3, here we're subtraction. We know it becomes division, so that's log of 7 divided, and we're going to go ahead and move the 2 up, divided by 12 squared. Which then that becomes log of 7 divided by 144. Okay, example 14. Again, remember sum, we multiply. Okay, so this becomes equal to log base 6 of 4 times 9. Well, 4 times 9 is 36, so this becomes log base 6 of 36. And then this actually, we know, is log base 6 of 36. Well, we ask ourselves, well, 6 what, right? So what power gives you 36? The answer to that is 2. So this equals 2. Okay, so here we're subtracting, so it becomes division. So that becomes log base 5 of 100 divided by 4. Well, 100 divided by 4 is 25, so that's log base 5 of 25. Well, you ask yourself, 5 raised to what power gives you 25? The answer to that is equal to 2. All right, last example is use change of base to evaluate. Now, we rewrite this as log of 8 divided by 2. Okay? And then this becomes log of 16 divided by 8. Okay? All right, so that would finish up examples. Start working on your assignment and have a wonderful Wildcat day.